Technology. We use it every day from computers to phones, but has technology actually led to a negative association in productivity? That's where my experiment comes in which I measured both productivity and technology and used a test to figure it out. But we encounter our first problem. So, how are we going to measure the number of minutes used on technology when we can't really control it because I have school and other tasks that are much more of a priority? To account for these limitations, I therefore tried to find if there's an association between the number of minutes used on phone the night before and productivity. This leads us to the second problem. How do you measure productivity? And so for this experiment, I used a human benchmark test to measure the productivity rates. And in order to show a better representation of productivity, I did all of the tests and compiled them into a Google Sheet. So I would either have to be doing multiple regression tests for this experiment, or I would have to be doing ANOVA testing. But now, there's actually one superior way of approaching this experiment without using these two tests, and that is standardization. So I was able to perform only one regression test by standardizing each score on the benchmark tests using the corresponding percentile. So instead of multiple response variables, I only had one quantitative response variable. Now to do the experiment. So for my experiment, I had two treatment groups, either treatment 1, in which I got 0 to 15 minutes of phone time use on my bed the day before, or treatment 2, in which I got 45 to 60 minutes of phone time use. I didn't use an interval from 16 to 44 minutes because it yields similar productivity rates. The difference between 29 minutes and 30 minutes of treatment is like same. And so I just used these two intervals. Now, using these two treatment groups, I can assign the treatments for the 30 trials. So I randomly generated 15 numbers from each treatment group, and then I randomly sorted the order using Google Spreadsheets. When I did the experiment, I replicated it 30 times over a course of 1 month. Some variables I controlled were hours slept, the computer I used, the order I'll be performing each test, which is from the typing test to the sequence memory test, and lastly, I controlled the brightness of my phone to be maximum. And now here's a summary of the data I collected over the 30 days. Now for the inference test. Although I didn't do it, I can still explain a gist of the test. So first, I will have to compute the percentiles, going through each of the scores and standardizing it. This leads to all of the table cells becoming individual trials instead of the 30 trials. So now we have 240 trials. Then after linearizing the data if needed, we can plot the graph, the residual plot, both the scatter and dot plot, the least squared regression line, and also the equation. Then we can finally go to the inference procedure. Now for the inference procedure. We'll be performing a linear regression t-test, and so the null hypothesis will be that there is no linear relationship between the variables minutes spent on the phone the day before and percentile. So beta will equal 0, where beta is the true slope of the LSRL relating the two variables. And then the alternative will be that it's negative, because we're trying to see if there's a negative relationship between the two variables. Now for the do and the conclude part. So of course, when you do the experiment, you will get a p-value and a t-statistic, although unknown right now. And then the degrees of freedom is known to be 238 in this experiment. So for the conclude part, it's pretty generic. With the calculated p-value, we can conclude whether there is or isn't convincing evidence of a negative linear relationship between the two variables. Although we don't have a p-value, we can still reject or fail to reject the null hypothesis. This is due to many scientific studies being conducted showing that using phones on the bed disturbs sleep, and therefore we can most directly assume that activities performed the next day would also be disturbed, and so the productivity would go down, would decrease. So we can just assume that we reject the null hypothesis and that there's a negative linear relationship between the two variables because of science. Now, because of our assumed conclusion in that we reject the null hypothesis, we could have actually made a type 1 error in which there is actually not a linear relationship between two variables. So a consequence of making this type 1 error is that people would follow our advice and lower their screen time, even though in reality there is no increase in productivity with a lower screen time. But, you get more sleep. Therefore, from this experiment, we are only able to generalize results for people like me because I tested myself in this experiment. The placebo effect could have taken place in this experiment because there's no blindness involved. I needed to know how many minutes I would spend on my phone the particular day, giving away which treatment I'm in. Some other variables that I didn't control that could have been confounded with my experiment are noise stimuli, quality of my sleep, and misclicking. Therefore, if I were to do this experiment again, I would have probably addressed these and potentially other variables in my experiment to make it more accurate, unbiased, and better to be generalized over a population by using more test subjects. Thank you.